Good day, everyone! We are the Group 7 and we will be discussing about Chapter 12, the ANOVA, short for Analysis of Variance. I am Leslie May Bugnut and together with Christine May Santos, we will be discussing about the one-way analysis of variance. Weren't you curious on testing the difference of more than two means since in Chapter 9, we have already discussed about testing the difference between two means. So what if there are more than two means? So let's say there are three means or more than three means. Others may say, for what? We may use t-test just like in Chapter 9 since it is still applicable. But wait! This is the reason why there is analysis of variance. So when an f-test is used to test a hypothesis concerning the means of three or more populations. Going back to the question a while ago, why can't we just simply use t-test just like in Chapter 9? So these are the reasons why t-test is not used in comparing three or more means. So first, when you are comparing two means at a time, the rest of the means under study are ignored. So halimbawa, meron kang three means and kung gagamitin mo yung t-test na dalawang mean lang ang pwedeng i-compare at a time, hindi mo muna papansinin or isi-set aside mo muna yung isang mean. Kasi nga, two means at a time lang ang pwede doon. But with the use of the f-test, all the means are compared or can be compared simultaneously or at the same time or sabay-sabay. Second, when you are comparing two means at a time and making all pairwise comparisons, the probability of rejecting the null hypothesis when it is true is increased. Since the more t-tests that are conducted, the greater is the likelihood of getting significant differences by chance alone. So, pag nagko-compare ka daw ng dalawang means lang, mas mataas yung probability na i-reject mo yung null hypothesis. Ano ba yung null hypothesis natin? Diba, all means are equal. So, pag ni-reject yung null hypothesis, ibig sabihin, hindi equal yung mga mean. Dahil pag mas maraming t-test daw ang gagamitin, mas malaki din yung chance na magkakaroon ng significant differences sa mga means. And lastly, the more means there are to compare, the more t-tests are needed. So here is an example. For the comparison of three means, two at a time, 3 t-tests are required. And for the comparison of 5 means, two at a time, 10 tests are required. So sa unang example, so halimbawa daw is meron kang 3 means. So let's say mean 1, mean 2, and mean 3. 3 t-tests are required. Kasi nga, every t-test, dalawa lang ang kaya niyang i-compare. So, mean 1 and mean 2, mean 1 and mean 3, and mean 2 and mean 3. So, di ba parang time-consuming masyado or mas maraming t-test ang kailangan. Unlike kung gagamitin natin is yung f-test or the analysis of variance. So, here are the assumptions for the f-test for comparing three or more means. For the first one, the populations from which the samples were obtained must be normally or approximately normally distributed. So, kailangan normally or approximately normally distributed yung mga populations kung saan galing yung mga samples. Second, the samples must be independent of one another or meaning one sample must not affect the other. Third, the variances of the populations must be equal. And take note that even though you are comparing three or more means in the use of the f-test, variances are used in the test instead of means. There are two different estimates of the population variance. The first one is the between group variance, which involves finding the variance of the means. So meaning, this includes the differences in the means. The next one is within group variance. It is made by computing the variance using all the data and is not affected by differences in the means. So if there is no difference in the means, the between group variance estimate will be approximately equal to the within group variance estimate. Bakit? Kasi nga, sa within group variance, it is not affected by the differences in the means. At kung walang difference sa mga means, meaning yung between group variance ay equal lang sa within group variance. And so, the F-test value will be approximately equal to 1. And also, the null hypothesis will not be rejected. Yung null hypothesis na nagsasabi or nag-i-state na yung mga means ay equal will not be rejected. Kasi nga, wala siyang significance. So, meaning, totoo yung null hypothesis na equal ang mga means since there is no significant difference among them. However, when the means differ significantly, the between group variance will be much larger than the within group variance. Bakit siya larger? Kasi nga, yung within group variance, hindi siya naaapektuhan ng mga differences ng means. And yung between group variance, hinahanap niya yung variance sa mga means. So, meaning, kasama din doon yung mga differences ng means na nakakapagpadagdag. Kaya nasasabi na much larger yung between group variance sa within group variance kung there is a significant differences among the means. And so the F-test value will be significantly greater than 1 and the null hypothesis will be rejected. The null hypothesis will be rejected since the means are not equal and there is a significant differences between them. And since variances are compared, this procedure is called analysis of variance or ANOVA. And for a test of the difference among 3 or more means, the following hypothesis should be used. So for the null hypothesis, it just states that all means are equal, meaning mean sub 1 is equal to mean sub 2 is equal to up to mean sub k. And for the alternative hypothesis, at least one mean is different from the others. And the degrees of freedom for the F-test is, for the degrees of freedom of the numerator is equal to k minus 1, where k is the number of groups. And for the degrees of freedom of the denominator, it is equal to n, capital N minus k, where capital N is the sum of the sample sizes of the groups, capital N equal to small letter n sub 1 plus n sub 2 plus up to n sub k. And the sample sizes need not be equal. And the F-test to compare means is always right-tailed because it can never be negative. For example 12-1, lowering blood pressure. A researcher wishes to try 3 different techniques to lower the blood pressure of individuals diagnosed with high blood pressure. The subjects are randomly assigned to 3 groups. The first group takes medication, the second group exercises, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded at an alpha equal to 0.05. Thus, the claim that there is no difference among the means, and the data are shown. For the medication group, the reduction in each person's blood pressure are 10, 12, 9, 15, and 13, and the mean is 11.8, and the sample variance is 5.7. For the exercises group, the reduction in each person's blood pressure are 6, 8, 3, 0, and 2, and the mean is 3.8, and the sample variance is 10.2. And for the diet group, the reduction in each person's blood pressure are 5, 9, 12, 8, and 4, and the mean is 7.6, and the sample variance is 10.3, obtained using Excel. To start with, let us follow the 5 steps. So for step 1, state the hypothesis and identify the claim. Our null hypothesis states that the means are equal. So mean sub 1 is equal to mean sub 2 is equal to mean sub 3. And that is our claim. And for the alternative hypothesis, at least one mean is different from the others. For step 2, find the critical value. Since k is equal to 3, k is equal to 3 because there are 3 groups, the medication group, exercises group, and the diet group. And capital letter N is equal to 15 because there are a total of 15 individuals. So 5 individuals each group. So the degrees of freedom for the numerator, it is equal to k minus 1. K is equal to 3, so 3 minus 1 is equal to 2. And the degrees of freedom of the denominator, it is equal to capital letter N minus k. And capital letter N is equal to 15. So 15 minus 3 is equal to 12. And by looking at this table, the table H, at an alpha equal to 0.05, our critical value is 3.89 because our degrees of freedom for the numerator is 2 and the degrees of freedom for the denominator is 12. So our critical value is 3.89. For step 3, compute the test value using the procedure outlined here. For A, find the mean and variance of each sample. So these values are shown below the data. So here is our data. And the mean of the first group is equal to 11.8. For the second group is 3.8 and for the third group is 7.6. And the variance for the first group, it is equal to 5.7. For the second group is 10.2 and for the third group is 10.3. For letter B, find the grand mean. The grand mean, denoted by x bar sub gm, is the mean of all values in the samples. So the formula in getting the grand mean is the summation of x over n. So 10 plus 12 plus 9 plus 15 plus 13 plus 6 plus 8 plus 3 plus 0 plus 2 plus 5 plus 9 plus 12 plus 8 plus 4 divided by 15. So the sum of these values is 116, then divided by 15, which will be equal to 7.73. So this means that this is our grand mean. For letter C, find the between group variance, and it is denoted by S squared sub B. And the formula in getting the between group variance is the summation of n sub I multiplied by the square of mean sub I minus the grand mean all over k minus 1. So this numerator is also known or is also called as the sum of squares between groups, denoted by SS sub B. So by substituting, we have 5 here. And if you are wondering why it became 5, it is because in every group, we have 5 individuals. So 5 multiplied by x sub I, so the first group. For the first group, we have our mean is 11.8. That is why this became 11.8 minus 7.73, which is our grand mean. And it is squared all over 3 minus 1 because the number of groups is equal to 3. The medication, exercises, and the diet group. So 3 minus 1. Plus, since it is a summation, you will need to add the second group and the third group. So plus 5 times the mean for this is 3.8 minus the grand mean, which is 7.73, and square all over 3 minus 1 plus 5 times 7.6 minus 7.73 squared all over 3 minus 1, and which is equal to 160.13 divided by 2 equals 80.07. So this now is our between group variance, and or it is also known as mean square between group, denoted by MS sub P. And take note that this formula finds the variance among the means by using the sample sizes as weights and considers the differences in the means. For letter D, find the within group variance, denoted by S squared sub W. And the formula in getting the within group variance is the summation of quantity n sub I minus 1 multiplied by the variance sub I all over the summation of quantity n sub I minus 1. And take note that the numerator here is also known as the sum of squares within groups and denoted by SS sub W. And by substituting, we have 5 minus 1. So the 5 here came from the number of individuals or samples in the first group. So same with the second group and same with the third group. Multiplied by the variance in the first group, which is 5.7, plus 5 minus 1 multiplied by the variance of the second group, which is 10.2, plus 5 minus 1 multiplied by the variance of the third group, which is 10.3, all over 5 minus 1 plus 5 minus 1 plus 5 minus 1, arriving at 104.80 divided by 12, which is equal to 8.73. So this now is our within group variance, or it is also known, or it is also called as the mean square within group, denoted by MS sub W. And take note that this formula finds an overall variance by calculating a weighted average of the individual variances. So it does not involve using differences of the mean. So unlike with the first one, the between group variance, which involves using the differences of the means. For letter E, find the F-test value. So the formula in finding for the F-test value is the between group variance divided by the within group variance. So the value of our between group variance is 80.07 and the value of our within group variance is 8.73, and by dividing we have 9.17. So this now is our F-test value. And for step 4, make the decision. The decision is to reject the null hypothesis since 9.17 is greater than our critical value, which is 3.89. So, kailangan natin i-reject yung null hypothesis. Ano ba yung null hypothesis natin? That the means are equal. Hindi nga sila equal, kaya i-reject natin yung null hypothesis. And for step 5, summarize the results. There is enough evidence to reject the claim and conclude that at least one mean is different from the others. Ano ba yung claim natin? Yung claim natin is yung null hypothesis. Yung null hypothesis ay nagsasabi or it states that the means are equal. Hindi nga sila equal. So meaning kung hindi sila equal, they are, or at least one mean is different from the other. In summary, here is table 12-1, the analysis of variance summary table. So the sum of squares between group is denoted by SS sub B. The sum of squares within group is denoted by SS sub W. The degrees of freedom between group is equal to K minus 1, where K is equal to the number of groups. And then the degrees of freedom within group is equal to capital N minus K, where N is equal to N sub 1 plus N sub 2 plus up to N sub K equals the sum of sample sizes for groups. Then, the mean square between group is denoted by MS sub B is equal to SS sub B divided by K minus 1. And the mean square within group is equal, or it is denoted by MS sub W, and it is equal to SS sub W divided by N minus K. And our F-test value is equal to the mean square between group divided by the mean square within group. And by applying, here is table 12-2, the analysis of variance summary table for example 12-1. So the sum of squares between group is equal to 160.13. The sum of squares within group is 104.80, and by adding we have a total of 264.93. The degrees of freedom between group is equal to 2, and the degrees of freedom within group is equal to 12, and by adding we have 14. The mean square between group is equal to 80.07, and the mean square within group is equal to 8.73, and by dividing this, we arrive at an F-test value, which is equal to 9.17. That's all for my report. Good day and God bless.